Welcome to the factoring trinomials video. In this video, we are going to be specifically talking about how to factor things that have three terms. And all of them are going to start off in this form over here on the right, where you have an x squared, an x in the middle, and a constant term at the end. Every single one will look like this. What we are trying to do when we factor is rewrite the polynomials as multiplication problems or undistribute, because then we can solve them like the equations we solved in 7.4. Factored polynomial equations are much easier to solve because they help you deal with the extra powers on the variable. Now, for example, this one over here would change to this setup with two sets of parentheses. This is what you are looking for today. All of your answers are going to look something like that, where there's an x in both sets of parentheses. In the previous lesson, we had just talked about greatest common factors, so there was only really one set of parentheses. You saw some examples like this, but we didn't have to get there ourselves. We just were given that to start with. Now, there are going to be some pretty specific rules you have to follow with this, and it takes way more math than Algebra 1 level to be able to understand the why. So you really just have to be able to follow the pattern, okay? This method is called the AC method, and it's called the AC method because the standard form of a trinomial is called ax squared plus bx plus c. So A and C are referring to the first and the last number. Now, you can just call them first and last, or you can call them A and C. It's the same thing. I'll go over that a little bit more in just a second, but that's the name of it. The two numbers that we're going to end up putting into our problem, and I'm going to go ahead and cross out the word parentheses. We just need to find two numbers that add to the middle number and multiply to A times C, or first times last, if you would rather write it that way, because that's all the AC really means. And just a reminder that you should be able to redistribute or multiply out any problem that you, or any answer that you get to get back to the original problem. We're not changing the problem itself, we're changing the way it looks. It's going to still be the same thing, just in a different form that would be easier to solve with. Because we don't have equations, so we're not allowed to just add 2 to both sides because there's no other side. Now, there are going to be 4 steps. Your first job is to find the two numbers that multiply to AC and add to the middle number. Okay, that is most of the work right there. Not going to lie, step 1 takes the longest and is the most work intensive. Once you find those two numbers, the whole point of those two numbers is that we need to split up the middle term. Now, I'm going to go ahead and start an example to explain to you what that looks like before I go into steps 3 and 4. So for this first problem over here on the left, A would be the 2, C would be the 5. 2 times 5 is 10. So we need to find two numbers that add to 11 and multiply to 10. Now, most of you probably already know what I'm going for here, but I'm going to make a list. 10 is either 1 times 10 or 2 times 5. You need to pick the set that also adds to 11, which would be the 1 and the 10. Now that we know that our numbers are 1 and 10, we are going to split up this middle term into 1x plus 10x. Because 1x plus 10x is the same thing as 11x. So I'm not changing my problem, I'm splitting it up to sort of uncombine my like terms for the next step. The next step only works if I have 4 terms. It doesn't work if I have 3 because my job is to factor the GCF out of the first 2 and the last 2 terms. And I can't group those together like that if I have 3. There'd be an uneven amount in each group. So I'm going to look first at these 2 right here, 2x squared and 1x. There's not a number that goes into 2 and 1 other than 1, but they do both have an x. So you're going to put that x on the outside of the parentheses, and what's left inside is what's left over if you divide both of these by x. 2x squared divided by x is just 2x. 1x divided by x is just 1. Nothing can completely disappear. It at least has to leave a 1 behind, because something divided by itself equals 1. Then you do that same idea with the 10x and the 5. 5 goes into both 10 and 5, so we would put a 5 on the outside. These do not both have an x, so I can't put an x out there like I did on the last one. Then I just divide both of these by 5. Now, earlier I said that I was undistributing, right? That's what factoring is. Essentially, what I've just done is I've found something that multiplies to create what I had up here. X times 2x is 2x squared. X times 1 is 1x. And you don't have to write that out because it's going to make it look kind of crazy. But that's the whole goal. The reason why we had to be so specific about those 2 numbers, though, is because if we didn't do that, the last step wouldn't work out. And the last step is now to do the GCF one last time, but out of the entire polynomial. So if I look all the way across what I have at the bottom row, I see that both of these things, and by the way, I should have put a plus sign right there. Both of these have a 2x minus or 2x plus 1. So that parentheses part should always match. And if I take that 2x plus 1 out, this one's just x, and this one's just 5. So x plus 5 would be what's left. Now you do not have to cross through them like that. I just wanted to sort of show what was happening right there. Yeah, just gonna leave it. And that would be your fully factored form. Now, if it's easier for you to think about on that last step, the matching parentheses will always be inside the first one. That means the one that's on there twice. And the other parentheses is going to be your GCFs from the outside. So the x and the 5. And then the 2x plus 1 was written once because we were factoring that out. Now that is the AC method. Those 4 steps are quite a bit. So as I go through the next few examples, just keep paying attention to some of the patterns you might be picking up on. It gets easier the more problems you do, you get more used to the pattern. All right, the next problem, A is 3 and C is negative 4. 3 times negative 4 is negative 12. And I need to find something that multiplies to negative 12 and adds to 1. So I'm going to start just by listing. And I put a list of, or how to get them right here. To list all the factors, you just simply take that number and you divide by 2, and then 3, and then 4, and then 5, and then 6, however far you can go. So, for example, negative 12 divided by 2 is negative 6. Negative 12 divided by 3 is negative 4. And I'm not going to go to 4 because 4 is already in my list. That's how I know I'm done when I start repeating numbers that are already on the other side. Now, I want whichever one adds to 1. 2 plus negative 6 is negative 4. That's not 1. 3 plus negative 4 is negative 1. I want it to be positive 1. So all I have to do is switch the negative from the 4 to the 3. Because negative 3 plus positive 4 is 1. So if you get the right number but the wrong sign, just switch your signs. That's it. Negative 3 plus 4 is 1, so this 1x in the middle is going to split up into negative 3x and 4x. You're using the two numbers that you just found over there on the right side. And then you're going to find the GCF of the first two, 3x squared and negative 3x. Well, I just said 3 and x twice, so 3x is my greatest common factor. And then remember, you're just dividing. 3x squared divided by 3x. 3 divided by 3 is 1. I do not have to write that 1. X squared divided by x becomes just x, because one of the x's from the squared cancels out. Negative 3x divided by 3x is negative 1. 3 divided by 3 is 1, and then the x's divide to 1 as well. On the other side of this, 4x and 4, negative 4, I can divide those both by 4, obviously, which would leave me with x and negative 1. 4x divided by 4 is just x. Negative 4 divided by 4 is negative 1. Do my parentheses match? You bet they do. So my first parentheses in my answer is that x minus 1, and the other parentheses is 3x plus 4. Because when I put that x plus 1 in front, it's like I'm canceling these two out, and that is what I have left for the other parentheses. All right, let's go on to number 3. And by the way, I'm only going to do the first 6. I feel like that's more than plenty. I left extras just in case we needed them. I really don't think we will. If you're still having trouble with it, just come see me, because it just means you might need somebody to work with you one-on-one. Now, the last one doesn't have a number over here. I can just make it a 1, but 1 times 12 is just going to be 12. And then I'm going to steal the list I used on the other one, 2 and 6, 3 and 4, but I don't need the negative this time because the 12 is positive. And I'm trying to add to negative 8. Now, 2 plus 6 is 8, right? We just need it to be negative, so we switch our signs. Negative 2 and negative 6 makes negative 8. So it'll be x squared, negative 2x, negative 6x plus 12. Or minus 2x minus 6x plus 12. And then if you don't like drawing the circles or the boxes like I did over there, you could just draw a simple line right here. X squared and negative 2x, you can take an x out of both of those as a common factor, and you would be left with x minus 2. You can also think of that as x times what is going to get you back to x squared. X times x is going to get you x squared. And then for the next one, it would be x times what is going to get you negative 2x. And that would be negative 2. X times negative 2 is negative 2x. So you can think of it as multiplication backwards if that helps. On the right side, one really important piece, if there is a negative right here, your GCF is going to be negative. And then 12 and 6 can both be divided by 6. Now, negative 6x divided by negative 6 is just x. 12 divided by negative 6 is negative 2. My parentheses match. They both have an x minus 2, so I put that out front. And that leaves me with x minus 6 in the other parentheses. All right, for the next 3, I'm just going to go through the motions, explain kind of how I'm getting what I'm writing, but I'm not going to go through all the steps and all the explanations on these. All right, 5x squared minus 2x minus 3. 5 times negative 3 is negative 15, which could be negative 15 doesn't divide by 2, but negative 15 divided by 3 is negative 5. and then 4 doesn't divide, and I'm back to 5 already, which is on my list. So those are the only things that multiply to negative 15. And if I add them together, 3 plus negative 5 is negative 2. So those are my two numbers. So that negative 2x becomes 3x minus 5x. Then you're going to find the GCF of the first two and the last two. On the first two, nothing goes into 5 and 3, but they do both have an x, which means you're just essentially taking the x's down by a power, because x times 5x makes 5x squared, x times 3 makes 3x. There you have it. On the right side, there is a negative in front, so I'm going to have to put a negative there. And on this one, they don't both have an x, and they don't both have anything that goes into 5 and 3. So all I do is I put a 1. You have to have a GCF, even if it's just a 1. Because then I'm technically dividing both of these by negative 1, which makes it positive 5x and positive 3. Which is good, because that's what was in the other parentheses. So 5x plus 3. And if I cross those out, I'm left with x minus 1. Second problem in the middle, 3 times 8 is 24. 2 times 12, 3 times 8, 4 times 6. See how quickly that goes if you just go in order? Then I don't worry about if I missed something that goes into 24. I've got them all. And I need it to add to negative 10. Well, 6 plus 4 is already 10. We just need to make sure we write them both as negatives. Again, you just switch the signs if you need the sign of the middle number to switch. And then you split it down the middle. 3x squared and negative 4x, I can take out an x, leaving me with 3x minus 4. Hopefully you're starting to kind of catch on to the pattern of when you just take an x out of those first two, look what's left. It's not different than it already was. Over here on the right side, just be careful because that is a negative 6. I kind of drew my line through it. So I'm going to take out a negative, and then 2 is the only number I can think of that goes into 6 and 8. And then negative 6 divided by negative 2 is 3x. 8 divided by negative 2 is negative 4. And I'll scooch that over just a little bit. It got kind of squished into my work. My parentheses match. That's the 3x minus 4. And if I cross those out, I'm left with x minus 2. Last one, and then I'll end the notes here. There's no number in front, so I'm really just trying to multiply to negative 30. Negative 30 divided by 2 is negative 15. Negative 30 divided by 3 is negative 10. Negative 30 divided by 4 doesn't work. Negative 30 divided by 5 is negative 6. 6 is already on the list, so I don't have to keep going. I'm done. Okay, I'm not saying you have to do that every single time, but if you need the list of numbers that go into it, that's how you find it the fastest. I need to add to 13. So let's see, 5 minus 6 is negative 1. 3 minus 10 is negative 7. There we go. But 2 plus negative 15 is negative 13. So I actually want to change it to negative 2 and positive 15. And then remember, those are the two numbers you're putting in the middle so that you can split it up. I can take out an x between the first two, leaving me with x minus 2. I can take out a 15 on the other two. That's a pretty big greatest common factor. 15x divided by 15 is just x. Negative 30 divided by 15 is negative 2. Voila, my parentheses match. X minus 2. Cross those out, and you have x plus 15. And that, ladies and gentlemen, is how you factor trinomials. There is a shortcut that you can use, but we are not going to learn it until we practice this enough that we've got it down.